Hi there, my name is Tamás and I am from Easy Automator. By today I will show you how easily we can use this spray gun to teach any kind of robot or cobot. And at the very beginning I would like to show you what is the expected outcome of such a kind of programming which can make your everyday life easier. So just enjoy. So this was a short demonstration about how it could work. Right now I just drive away with the robot, and I will show you how we can easily reach this anytime with any kind of robot for any circumstances. So keep tuned. Hello, my name is Tamás from Easy Automator. I would like to show you today how easily we can integrate the Easy Automator Teach Pen to any kind of manual tool what you might use in your workshop or production hall. So for this example, I just use a spray gun from Krautsberger, the HS30 model. This is a very high quality spray gun, and we just got it from the company Krautsberger for this demonstration. So thank you for this. And I will show you how easily we can teach the TCP of this tool, even if I'm just using two magnets to fix my teach pen on this spray gun. And you will see that this spray gun with this setup, so I just attach it with the two magnets, the teach pen. This will be saved and stored in the Easy Automator app, and you can select it later on just from a drop-down list, and then you are just ready to go to use your spray gun. So what we need for this, for sure, we need always, as a very first step, a valid RoboDK file, as we will have to start the RoboPathRack app. A valid RoboDK file is always defined that you have at least one robot, one valid tool, and one valid frame in this file. How to do this, you can find it in our other tutorials. I don't want to really explain it in detail. So I recommend you not to start with a file from scratch, but you should use a file which you already verified with the pen, only that you could really reach everything and you could use it, this file, you could use it just like as expected, okay? So once we have our file, the next step is to start SteamVR and to power on the tracker of our teach pen. I already have done this. You can see that one of the base stations and the other one is already online, and the tracker is connected and recognized. So that's fine. As next, as we will define a TCP of a tool, I get again my usual metal plate, and I just fix it anywhere. Most preferably at the position where the robot with the tool normally, with the defined tool, would reach this kind of position, because we will do a kind of recording, not with the robot, but it is quite a good stuff. But where you place it, this is really up to you. This is your choice. I just fixed it here, and we can go for the next step. So what is the next step? So please, from the start menu, just go for the after work. On my PC, it's called RoboPathRack After Work Tools. Later, this will be called Easy Automator After Work Tools. And if you hit it, then a folder opens up, and here you can find all of our useful tools for preparing, controlling, monitoring, and adjusting of programs. In this case, we will use the manual two calibration files, step 1, 2, and 3, and we start with the step 1. So I just double click it, and you don't have to do anything else. You just wait that the program runs through, and we will get the message process completed successfully. That's great. So you can see I have the measure offset tool in my RoboDK file. I just hit as an active tool, and I save the station. Okay, this is very important. Please save the station at this stage. And once we have done so, just start the RobPathRack or Easy Automator app. And once it's open, you can see that the Teach device is the pen right now. So I just hit the Options button. And within the options, I just go to the Teach device and VR settings section, and here to the Teach device, and I select Tracker Only. Okay, Tracker Only. I save it. Please restart the app. Okay, just do this. I restart the RobPathRack or later Easy Automator app, depending on the version what you are using. And you can see here, this is very important, the tool which is selected at the moment, this is the automatic spray gun. So I just select the measure offset tool. Okay, the Teach device is tracker only, the tool is the measure offset tool, and I will just hit the start recording. Why I will do this? So normal, we will just go through normal with the origin X, Y origin, initial calibration, and then I will come with my spray gun to this TCP calibration tool, and I will just record a couple of single points that I can really draw a kind of virtual sphere around this point. Okay, so just do this. At this point, you shouldn't be worried about if you can't hit the accuracy with the tool. It really doesn't matter even if the inaccuracy would be 1 meter offset. It doesn't matter. What's matter is origin X, Y. So the sequence, this matters. Right now the robot already moving around on my screen, and I'm just coming back to the origin, hit again the button. As expected, I just get a failure message that the inaccuracy is more than 5 millimeters. In this case, this is indeed 11 millimeters. So what I will do right now, I will just come exactly with the TCP, with the very middle of the Krausberger spray gun. This is my TCP, which I defined in this case. I'm just coming to this point, okay, and I'm just using this button, and I'm just recording a couple of points. I have to take care that I don't move either the tool nor the pen. The more accurate I can do this, and with the more points I can do this, the better will be the result later on. So I just has done this with 9 points for this demonstration. I recommend you to record at least 30 points with the highest accuracy. So this is depending on your needs. The highest accuracy you record these points. So not moving around, you are really hitting exactly this point with the TCP, with the expected TCP of your manual tool, the better accuracy results you will get later on. Okay, so this is very important. Take your time. Here you can see I have this. Just for safety, I've just saved this file. And right now I will right-click the measure offset, and I just hit the define TCP. So now here you can see that the measure offset is the selected tool, which is great. We are using the joints, and we are using the Elite Robots CS 63, which is correct. So everything in my setup is exactly as I want to have. And you can see I have recorded or together 9 points. So I will change the minimum 4 to the 9. And with this one, you will see that I have suddenly 9 points to define. So how do I do this? How to make it that you can see? I just double click the first one. You can see that on the screen the robot gets to this point, and I just get this point. 2, 3, 4, 5, 6, 7, 8, and 9. Okay, in my particular case, the TCP error was defined with 172 millimeters. I just hit update and I confirm this. And with this one, the new TCP, um, this TCP was defined exactly with this particular fixture and given given orientation of the pen. Okay, so as next, we can remove all these points. We can remove the program which we created earlier. We just save the station again. And before we move to the next point, um, we have to come to the tools, and we just let the step 2, the manual tool calibration step 2 files, we just double click it and let it run. With this action, we are just transferring the TCP setup of the measured offset tool. So right now, here's the window. Please select the tool which should be used later for the recording. So this is the measure offset tool, okay? This is the measure offset tool, what we are working with. So, okay. And right now, we are just transferring into the system this kind of particular TCP setup. Here you can see the process completed successfully. There's the message. Okay, so once we just save it, as next, we will define the orientation. We will define the orientation, the right orientation of the tool. So right now, we just know where's the point, but we do not know how this point should be orientated once we start with. So this is my robot. Normally, if it looks in this direction, I want to have it in this manner. I want to have my spray gun for the processing. So I will have to come to the 0 point, and I will have to make exactly the angles in any kind of direction, exactly so uh, compared to the surface as I want to have it here in the real life. Okay, so how to do this? Um, we're just coming back to the tools, and no, sorry, forget it. So the measure offset tool is the active one. We are just coming into the raw path track tool. We just start the raw path track tool. You see that the teach device is the tracker only. So we just come into the options again, and instead of the tracker only, we select the measured offset. So this is the tool what we just defined with the TCP. We save it. Please restart the app. So follow the instruction. We just restart it. And right now you can see the measured offset tool is the teach device. Very important again, select tool. So this is the measure offset tool, okay? This is the measure offset tool what we are using right now. And I just hit start recording again. So I just come through the normal sequence of the initial recording, origin, X, Y, the robot already moving around, Next, and as you can see, right now I can produce 3 millimeters inaccuracy already, which is very, very good. So I didn't wanted to optimize it on the accuracy at the moment. And right now I will do nothing else. I'm just coming back to the origin. So this is very important. So we have to come back to the origin point and uh, really have to position our device exactly compared to the surface, exactly so as we would like to spray. So this is the Z direction. So this must be then perpendicular to the table, and with the bin on the top, we just have to really turn it on a manner that this is really absolutely parallel to the edge of the desk, because this is the position, this is the orientation which I would like to use later on. And I just record one single point. So if I raise it, this is exactly the way how I want to have it in my hand, this tool. And this is exactly the orientation which I want to use for this TCP during the processing, okay? So I recorded this one point, finish recording. You can select this one point. If you don't do this, doesn't matter. You can select anything else, we will ask it. So right now, very important, we save the station and we come back to our Afterwork Tools folder, and we are just going to the step 3. So we just run manual tool calibration step 3. I just double click it. First, it will raise the question, I think, which tool should be modified. So this is the measure offset. Okay. Which point is the reference for this target? This is the P1. Okay. And that's all. The process completed successfully. So right now, we can delete this program. We can delete this point. We can save the program. And you can just come to the raw path track app. And we will rename the measured offset tool. So to do so, I will just remove this tool from this file, save it again. I'm just coming to the options. And at the measure offset, this is very important. You cannot undo this. You hit edit. And I just type the name, Krautsberger HS30. Just check out Krautsberger HS30, exactly. I hit OK. So with this one, I have my new tool in my tool set. So next time, if I want to use this tool, I just come along, attach the pen, come to the options. You just select Krautsberger, and that's all. Okay. So just to make it clear how it works, I just doing a quick recording. For this, I will use this chair. Try to fix it somehow with some tape. Okay. So the teach device is the Krautsberger one. The tool itself in our file is the calibrated tool on the robot. So what do I do right now? I'm just start recording, and I'm just coming through pretty normal, like always. Origin X Y back to the origin. Okay. And I just make it simple, okay? So I just recorded something here in front of this chair. I just hit finish recording. This is just for the demonstration for you that we have done everything correct. So the robot can reach all of the points. Okay, I'm satisfied with. I hit generate robot program. I update this. With a double click, I just transfer this to the robot. And right now I'm just coming into the task and I just read in which I have recorded right now. Open. And we just let it run. So we are just coming here with the robot, and I expect that the robot will come exactly to the points what we just recorded. So easy. So you can see it took approximately 20 minutes because I was explaining all the time what to do. Once you are getting used to, you will be able to cover it within 10 minutes or so. To add any kind of manual tool from your production, then you can use your manual tool with the normal procedure as you would use this tool for manual processing. You can attach either with the adapter slots of ORS or with any other tool, any other technical solution, the pen to your tool. It's important to know for sure that the pen should come exactly always to the same position back to your manual tool to get the highest accuracy. Okay, so if you change the position, if you shift it in any kind of direction, then you will have an offset with the manual processing. But once you can make it sure that this is coming back exactly to the same position, you will be able to reproduce these results anytime. Okay, then you just have to select it from drop-down menu, and then you are ready to go. You can use it for preparing um, with the spray gun. You can use powder coating gun. You can use welding gun. You can use grinding, polishing tools. You can use any kind of tool, dispensing tools. You can use it for any kind of tool, and you can always choose. You have the freedom if you're using the pen itself as a teach pen, or if you want to attach it to any kind of tool. You can save as many tools as you want in our application. There are no limits, and I hope it helps you a lot in the future to automate your processes.